Hi everyone. I was cut off earlier when we were well. Actually, it wasn't cut off. I didn't record. I didn't press record fast enough, uh, and I think Robin was the one who pointed that out, and I didn't see the comment. What we were talking about earlier today, and I would like to go over these assignments before they come out because I think a lot of you are getting intimidated by the sheer amount of text that I end up writing. I'm a visual kind of guy, so let's try and do this in a visual way. Here's what we're doing for this assignment. We are effectively, I have given you three classes already. I've given you a media library. This would be something like what, let's say I have an NVIDIA Shield downstairs in my basement with and a Plex Media server on top of it, on that essentially. So I have all my movies and all my TV shows that I've collected over the years into this media server. It allows me to watch those shows anywhere I want. So the media library is my collection of all my movies and TV shows. Or the media library has a collection. It is the interface allowing me to get access to that collection. And a media collection is just a whole bunch of media objects. In our case, it's just going to be the information about the media. You're not playing a movie or anything, but it is each of these objects, each of these media objects has the information about a TV show, a particular episode of TV, a particular movie, a particular album. You could even have it as a particular, or just one track if you wanted to for music. It is just some form of media. So my media library has a media collection, and the media collection actually is composed of a whole lot of different media files. In fact, the media collection that I gave you is actually an array that automatically adjusts its size, but you could have used a linked list or something else like that. But this is given to you. You will have to make one change into it. You'll have to write the find function for it. But our media collection, again, you might have to write the find function or do something with find function there. And our media files, again, you may have to add a find function. We can look at that in a bit later. The media itself, every media file, it has some characteristics. It may have a genre, it may have a type of media, I think a genre, type of media, file location, like the address for where it's located, and the name of the file. 4 things. That doesn't properly describe all different types of media. A movie, for example, has a director. It has an IMDb database location, for example. It has a URL maybe, or it has the list of actors. It could be anything that you want. I left it fairly simple, but you can make it as complex as you want it to be. TV media, same thing. You'd have the name of the TV show, the actual episode of the TV show, what season it's in, maybe the actors in it, that sort of thing. The length of the show. So your job is for week 1, is to make 2 new types of media that extend from the media class. It's either a movie or a TV show or TV media. It could be an album, so music. It could be a comic book. It could be a book. So you'll extend the media class, and then in week 2, what you're going to do is you're going to make up another class, whatever you want it to be. You're going to extend your previous class. In this case, for this example, I'm making a long movie media object. And that might be something like Lawrence of Arabia, or maybe ask your parents what that is. There used to be a time when your movie wouldn't actually fit on one DVD or one VHS tape or whatever the case you're using. You'd have to on the film reel wasn't long enough, and so they'd have to swap film reels. So you could think of long media being an extra long movie, for example, or the Lord of the Rings, the 4-box DVD set, where there's 4 different discs that you can go through, right? They're still bundled together, like extra features, maybe extra features movie media, right? Whatever you want it to be. That's your job, is to play around with this and think about what kind of information you need and how to make it all work, how to make it all fit together. It's one of those things I can talk until I'm blue in my face. Until you do one of these things yourself, it's not going to really sink in. Okay, so that is part 1 of what we're looking at, and hopefully I don't have anything overly incriminating here. So here's here would be only a 3-line version of it. This thing could be thousands of lines if we wanted it to be. In the example I gave today, it would be I have a movie type, a music type, and a TV type. What we have for each line is a set of pairs. We have the field name and the field value over and over and over again. So the field name is media type, the field value is TV. The field name is name, the field value is Buffy the Vampire Slayer, School Hard 2-5, Season 2, Episode 5. Music, this System Only Dreams in Total Darkness by The National, for example. And it's of type music. It has this particular size for the file. Oh, file size is another part. But again, there are fields that, like, maybe not genre, but let's say album, what album it's from. There are fields that are not actually in all of these different types of media. So an album or a music file is different than an episode of a TV show, which is different than a movie. And so there'll be individual fields here. These are pairs, a field name and field value. There are pairs of values, field name values, that are not in all of these different rows because they're different types of media. And so your job is to, when you make a TV media object, then you would read in the appropriate fields from that. Not have any of these fields just left out. My media library, if I want to look at this, I essentially create a media file. I give it a tab text file, tab delimited text. Oh no, this is, I will get a single line of that file. So all the file reading, all of that kind of stuff is done for you. The one thing that's not done for you is this find function. But when we are loading in a file, this is a text file that we're going to load in. We're exporting the library out to a text file. We're printing out the contents of the library. We can create individual media files by passing in the tab delimited line of text that we have there. And that will make the appropriate type of media fully set up. Okay. Look, we have even overloading. Here's create media with a single string tab text. Here is create media with the media type text name, something like movie, for example, and tab text. So essentially this would then call, find out that field, this field here, and then call this function. So the media library is sort of our interface. When we call stuff, here we go. When we call stuff, we will simply load a file. This file, by the way, if you had noticed, this main method will take in arguments from the user. If no arguments are provided, we have a default to go to. So if I run from Visual Studio, it'll go to the default. If I run it from the command line, if you want to try that, it'll go through whatever command line arguments you give me. Okay, but it's going to use the default anyways. It will then print out the library. You should also test out your code in other ways. Maybe call the find function a bunch of times. And then you're going to export your library back out. And that will save another file, make a brand new file with the contents of your media. So what I had here at the end, the new file I'm going to generate should look exactly like this. Theoretically. I don't want to override the original file though, just in case I have a bug in my code. Okay, my media collection is just a whole lot of media. So when I add, I just keep calling add, and I add a media item to it, and it spits out how many items are in my media collection. And if I run out of space in that array, I dynamically generate a new array, move everything over, and keep going. So it's essentially an unlimited sized array to keep all my media. So it could have 5,000 songs or 20,000 songs. I think my music collection ended up being over 10,000 songs. It was something ridiculous. So after a while, yes, back in the old days, people used to collect music rather than just stream. So maybe I might want to get a particular element in my array. It could also be, if I was using a linked list, it would do the same thing. Get me the 5th thing in the collection. Get me the 17th thing in the collection. can get the size of my collection. I can clear my collection. I can output things to a file. I can print the collection. All of this was given to you. The key here is that the media file itself, let's look at the actual class itself. We have some public functions, toString, and we have a constructor, and this. We also have how we can extract fields, get the media type, for example, get the field information. These are protected functions, meaning that no one else has access to it unless it's a child of mine. So no one else can call extract fields other than myself or child classes. Okay, your job is going to be to write new versions of media, so TV media, for example, and plop and extend this class, like we did in the synchronous class today. I'd also like to point out that we had examples of enumerated data types, and the whole reason for this, or to do this down here, is that I really don't want to have to keep throw around or move around big things of text. Why? Because first of all, it's ridiculously easy to accidentally spell this wrong or spell this wrong, right? It's easy to misspell things. And if you misspell something, you want an error to say, hey, you have a mistake. Okay. But not only that, but I don't want to keep around just a number, because if I have the number 1 all throughout my code everywhere it's supposed to be representing alternative, I'm not going to remember that 2 minutes from now, let alone 2 weeks from now. What I want is, I want to give it a name, like music genre alternative, keep using music genre alternative everywhere, but under the hood, what the compiler sees is just the number 1, so that the human can read the code. The compiler doesn't need strings and long text. It just has numbers that it can play with. So I can say, is this equal to music genre alternative? If so, it's alternative music. Great. Similarly, with an enumerated class, I say, is it media type book? And if it is, great. I'll use that. Or is it a movie? Or is it a generic media type? Or is it music? Is it TV? This is the example I worked through myself to just that I'm going to be passing out to you later. Was collaborative music, when there's like a compilation album, or there's multiple people working on one song together. It's not just this one person or this one group. It's a one-time off pair of people or a group of people. That was just one of the options you could choose. So this allows you to quickly say, hey, which kind of media type are you? And you can just give it a number, essentially, by using an enumerated data type. Here I have the individual field names that I'm trying to match up with. And then I might have something like, it might be media type media, media type movie, media type TV. And so I have these pair value name field, name value pairs. There you go. That's the proper term. And if I go to media.cpp, this is what I'm actually doing. I get some tab text, this string of tab text, if I'm extracting all the fields. So I will call extract fields right here in my constructor. So I get this line of text that's separated by tabs. I can show it to you one more time. This thing, like this thing right here. And there, that thing. I'll get a string like that. And then I will, here's my media, I will extract all the fields based off of that line of text. If I go to extract fields, you'll see this in action. I will get for each field number, so starting at 0, 0, 1, 2, 3, 4, 5, until I run out of fields, I will pull off the next pair. And so I'll pull off a pair. So I'll get a string, I will get a pair of strings, the name and the value. So I will get, for each pair of strings that I get, I will then set whatever internal data I have. So if it says playtime, or if it says, let's say name, well, the name field would be, I'd have the first element of this pair would be the name, would it be name, the next field would be the name of the file. When I set field info, I will set the name in that object. So this extract fields, all it does is it pulls all the text, all the information from the text file and sets my variables. That's all it's doing. Here is set field information. If the field name is genre, then I'm going to set the genre to unknown. If the field that I'm looking at right now is the field file path, then I'm going to set the file path to whatever the second field was, right? The value. If the field name is field name, then I set the value to the name to whatever the value was. I'm just storing the data from the text file and keeping it around in each of my objects. So I'm going to have to make this for each subclass, because the media file knows nothing about things like seasons of TV and the like. So if I'm doing that, I'm going to have to extend set field info, and you're going to have to fix set field info to make sure it's working correctly, because it's not going to work correctly right off the bat. Okay, I think that's all the big things I wanted to go over. So we have a media library, which has a collection of media. That collection of media is a whole bunch of media files or objects. I will read in a text file, which that code's given to you. You don't have to use it if you don't want to. There is no need for you to use any of the provided code. It's just more work for you. I read in the text media file, and then I subsequently pull, so then after that point in time, I will fill in the values for my media object based on that. And now I can print off the media object if I want to the screen. I can save it to a text file, or I could search my media library for, directors named Jackson. Hopefully that's going to compile. Let's have a look. We'll find out. Okay, then let's run it one more time, and then let's run it and see what happens. Hopefully it doesn't blow up on my face like half my things do with C out and C in. There we go. So here is what it's output. That's what it's outputting when I read in the file. I created three media objects, and then I wrote that information back out. Notice file size is there, the file path is there, the name of the file is there, or the name of the movie media is there. The type of media, it's all media. I've lost information because I don't have TV media. I don't have movie media. The thing, when I export it out again, I only have fields associated with this generic media class. So your job, you can modify media library.txt all you want. Your job is to read in that text file, spit out the exact same text file ideally, and be able to search through and use that text file in ways. It's intentionally very open for you guys to play with and have fun with, but your job is to think about how the code all works together and then make new classes. Okay, with that being said, I'm going to take my leave of you guys. Thank you very much for listening, and hopefully that makes sense. Please ask questions early if you get when you get the chance, because I'd rather catch problems early rather than later. Thanks everyone. Bye.